Hello everyone, my name is Mr. Asnake and I'm a physics lecturer at Awasa University. In this session, we'll have discussion upon vectors. እኔ መምህር አስናቀ ኃይሉ እባላለሁ። በአዋሳ ዩኒቨርሲቲ በፊዚክስ የትምህርት ክፍል መምህር ነኝ። ዛሬ ጠቅለል ባለ መልኩ ስለ ቬክተር እንነጋገራለን። መልካም ቆይታ እንዲሆንልን እየተመኘው ትምህርቱን እቀጥላለሁ። That's good. Of course, we'll see in depth in detail about vector physical quantity. But I'm interested to give a highlight about a scalar physical quantity. Great. A scalar physical quantity, as you know, is a quantity that is completely specified by number and unit. ይህ ስካላር ኳንቲቲ የሚባለው ወይም ይህ የቁስ ባህሪ በመጠንና በአሃድ ብቻ የሚገለጥ የሚታተት የሚነገር የሚወሳ ይህ ፊዚካል ኳንቲቲ ስካላር ኳንቲቲ ይባላል። Examples of scalar physical quantities are mass, time, volume, speed, and etc. Great. Scalar obey the rules of ordinary algebra. Great. Now vector physical quantity. A vector is a quantity that is specified by both magnitude and the direction in space. Or in other words, vector is a quantity that requires both magnitude and the direction to express in depth in detail. Great. Examples of vector physical quantities: displacement, velocity, acceleration, momentum, force, and etc. Great. Vector obeys the law of vector algebra. The law of vector algebra are the rules that govern how we manipulate vectors, which are quantities that have both magnitude and direction. Great. Some of the key laws: vector addition, vector subtraction, scalar multiplication, dot product, cross product, and then etc. Great. If so, my dears, how we can represent, how we can symbolize a vector. Vector can be symbolized, can be represented by using either algebraic and then geometric method. So either algebraic or geometric method is very helpful technique to represent the vector. Great. Vectors are represented algebraically by a letter with an arrow over its head. For instance, look, this is letter V, and then this is an arrow over the head of V. So this stands for a vector known as velocity. Another example is, look, this one, letter P, and then the arrow over the head, and then this vector is known as momentum. Another one is, look, the letter F and then the arrow over the head of F. This vector is known as force. Another vector is known as S, and then over the head of S there is what you call it, an arrow over the head, an arrow, which is known as displacement. The magnitude of a vector is a positive scalar and written as either of these. Great. Another technique or method, as what we have discussed earlier, is the geometric method. By using a geometric method, we can narrate our vector in depth, in detail. Great. When dealing with the vectors, it is often useful to draw a picture. Okay? That means line with an arrow. This is very important. As what we have discussed earlier, the geometric method is one of the techniques to show, to illustrate, to narrate, to represent our vector. Great. If you attach beginning of vector A to end of another vector B, that means you are representing another vector between vector A and vector B. Okay, maybe this the new vector may be the resultant of a vector A and a vector B, and also we will see on the coming slides. Then the vector A plus the vector B is a straight arrow. Yes, from the beginning of vector A to the end of vector B. And now this new vector is known as the resultant vector, and then it should start from the tail of vector A and then end up with the head of vector B. On the next slide, we will see some important concepts about the vector in general. Great. Among them, the first one is a vector changes. Vector can change if we change magnitude. A vector can change if we change direction. A vector can change if we change both magnitude and direction. So a vector changes if it is magnitude or direction, or if both magnitude and direction change. Another important point is multiplication by a pure number merely changes the magnitude of the vector. If you multiply any vector by a positive number, what you will see? You will see changing the magnitude of the vector. In this case, the direction will be changed. Great. Another important concept is if the number is negative, that means if a vector is multiplied by a certain negative number, what you will see? The direction of the vector is reversed. Another very important concept or point is when a vector is multiplied by scalar like time, mass, temperature, the new vector also becomes different physical quantity. Example, so if you multiply acceleration with the time, you will have as in the product velocity. Now velocity is another physical quantity. What if you multiply velocity with the time, you will find a displacement. And now, so when a vector is multiplied by scalar, the new vector also becomes different physical quantity. Vector addition. What do you understand from the word vector addition? If you sum two or more vectors, you will find a single vector. This phenomenon is known as vector addition. This vector addition is nothing. It is a way to find a single vector that is known as the resultant vector. A single vector that is obtained by adding two or more vectors is called resultant vector. Now, on the next, we'll see how we can find graphically a single vector. Resultant vector is the vector drawn from the tail of the first vector to the end of the last vector. Then we will find a single vector which starts from the first tail of vector to the end of or to the head of the last vector. This vector is known as a single vector or a resultant vector. Look the figure here. How many vectors do you see here? 3 vectors. Vector A, vector B, vector C. Great. Look, this is known as the resultant vector, that is vector R, which started from the tail of vector A and end up with the head of vector C. And now this single vector represents the total, the resultant vector of vector A, vector B, and then vector C. This is the way we can represent a single vector by using graphical method. Another method is known as program law of vector addition. Program law of vector addition is a method, a means to find a single vector of two vectors. Great. Look, the program law stated that the resultant vectors are of two vectors A and B is the diagonal of program for which the two vectors A and B becomes adjacent sides. Look this figure. This is a simply program, and then this is let it be vector A, and then let it be this is vector B, and then this side, as you know, the sides of the programs are parallel each other, and then they are congruent. Yeah, so this is vector B, this also vector B, this is vector A, this is vector A, and then this side and this side, they are congruent, and then they are parallel each other. So the same thing holds true for these sides. Great. Let it be this is the resultant vector of vector A and vector B, which started from the tail of vector A and then end up with the head of the vector B, and then this is definitely the resultant of vector A and vector B. But you may request yourself how we can find the value of the resultant vector of vector A and vector B. Great. Look, this is angle beta, this is angle theta, this is angle alpha. Let it be. Great. So look, all the 3 vectors, vector A, vector B, and then vector R, are concurrent. So concurrent means vectors are those that act on the common point. Great. Look this approach or technique, okay, to find the resultant value of vector A and the vector B, whose name is known as vector R. Ultimate goal is to find the value of R. እንግዲህ ቅድም እንዳወራነው የሁለት ቬክተሮች ዲያጎናሉ ይህ ሪዛልታንት ነው ብለናል። እንግዲህ ሪዛልታንት ከሆነ እንዴት የዚህን ዋጋ እናገኛለን የሚለው ነገር ልናይ ነው ማለት ነው። ይህ ትንሽ ትኩረትን የሚፈልግ ቦታ ስለሆነ አጽንኦት እንስጥ። ጥሩ፣ እስቲ ተመልከቱ ልጆች። Look my dears. So this is vector A, this is vector B, and then vector B is inclined by certain angle from the horizontal አይደል? Let it be that angle is pi እንበል። በሆነ አንግል አይታችኋል። ቬክተር B በሆነ ያህል አንግል ግድለት አለው አይደል? ከሆሪዞንታል ላይኑ በተወሰነ አንግል ኢንክላይን አድርጓል። በጣም ጥሩ። ይህን አንግል ፓይ እንበል። እንግዲህ ልጆች እንደምታውቁ ይሄ ቬክተር ኢንክላይን አድርጓል። ጥሩ። አንግሉን ፓያል። በጣም ጥሩ። ታዲያ እንደዛ ከሆነ የዚህኛው ኤክስ ኮምፖነንት ይሄ ነው ብለን እናስብ። የዚህኛው ቬክተር ዋይ ኮምፖነንቱ ይሄ ነው እንበል። በጣም ጥሩ። ያ ካል የኤክስ ኮምፖነንቱና የዋይ ኮምፖነንት የዚህኛው ቬክተር ሄድ ቱ ቴል ነው አይደል? ስለዚህ ስንት ዲግሪ ፎርም ያደርጋል? 90 ዲግሪ ፎርም ያደርጋል አይደል? በጣም ጥሩ። Great. Look this one. If so, እንደዛ ከሆነ if so, we have x component of vector B and then y component vector B, and then we know they are perpendicular each other. Great. So to find the value of by as well bx, what we have to do, we have to refer trigonometric function, nothing else, so that bx is equivalent with b cosine of pi, and then by means b sine pi. Great. ስለዚህ ያገኘን ማለት ነው። Great. I mean by referring what you call trigonometric function, what we have learned in our mathematics lesson, okay, in our previous class. Now look my dears. Now look this triangle. It is right angle triangle, yeah? R A plus b cos pi. Look this one. From this to this, a plus b cos pi. And then this is the height for the small as well as for the larger triangle, yeah? It is known as b sine theta, or simply the y component of b. And then it acts as the height for both, okay, the smaller triangle as well as for larger triangle. Great. If so, now this triangle is simply right angle triangle. In such a case, what we have to do to find the value of r, we have to use a Pythagorean theorem. Great. That means the square of r is equal to square of a plus b cos pi plus square of b sine pi. Great. And then look, square of r is equal to square of a plus b cos pi plus square of b sine pi, and then it becomes square of a plus twice of ab cos pi plus square of b, and then square of pi plus square of b square of sine pi. Great. Now square of b is common. ተመልከቱ ልጆች፣ ይህ የመጣልን ራይት አንግል ትራያንግል ነው አይደል? ራይት አንግል ትራያንግል ነው። ራይት አንግልድ ትራያንግል ነው። ስለዚህ የ90 ዲግሪ ተቃራኒ አር ያልነው እንደ ሃይፖቴነስ ያገለግላል። ይህን ስኬር ስናደርግ ስኬር አድርገን የምናገኘው የዚህ ስኬር ዋጋ ከዚህ ስኬር ዋጋ እና ከዚህ ስኬር ዋጋ ድምር ጋር እኩል ይሆናል። ጥሩ እና ይሄን ስኬር አደረግ ይሄንም ስኬር አደረግን ደምር ነው ከዚህ ጋር እኩል እንደሚመጣ እናውቃለን። ይሄው ስኬር ስናደርግ እቺን ስኬር ስናደርግ ልክ እንደምታውቁ a + b the whole square ቢሆን square of a plus twice of ab plus b square of b ይመጣ የለ ልክ እንደዛ ሁሉ a plus b cosine pi the whole square ነው አይደል? ይሄን ስኬር ስናደርግ ይሄ ይመጣልናል። square of a plus twice of ab cos pi plus square of b square of cos pi ይመጣልን። ከዛ ይሄን ስኬር ስናደርግ ይሄ ይመጣል። ሲምፕል ማትማቲክስ ነው። ከዛ አይታችሁ እንደሆን square of b common ነው ለሁለቱ ተርሞች። now square of b common for both terms. okay, so what we have to do, just take out the square of b as a common. አወጣን። ስናወጣ እዚህ ጋር የሚቀረን ምንድነው? square of cos pi plus square of sin pi እዚህ ጋር እንዳለ እነዚህ ተቀመጡ። ነገር ግን we know from the trigonometric identity this value is equivalent with 1. ይሄ እኮ ማለት አንድ ነው። ታውቁ የለ trigonometric identity ውስጥ trigonometric identity any አንግል ወስዳችሁ የዛ ስኬር ኮስ እና የዛ ስኬር ሳይን ቫልዩ አንድ ነው የሚመጣው። ይሄ አንድ ነው። ሞክሩ እስቲ 30 ውሰዱ፣ 45 ውሰዱ፣ 90 ውሰዱ፣ 80 ውሰዱ፣ ይሄ አንድ ነው የሚመጣው። ግሬት። ስለዚህ ማን ቀረ? ስኬር ኦፍ ቢ ቀረ። ስለዚህ ይሄ ተርም ምን ሆነ? ስኬር ኦፍ አር እኩል ይሆናል ስኬር ኦፍ ኤ ፕላስ ትዋይስ ኦፍ ኤ ቢ ኮስ ፓይ ፕላስ ስኬር ኦፍ ቢ ቀረ ማለት ነው። ግሬት። ስለዚህ ይሄ ቀረ ማለት ነው። አይታችኋል? ይሄ ቀረ ማለት ነው። ጥሩ ተመልከቱ። ቀጣይ ደግሞ ታዲያ እንደዛ ከሆነ አሁን አላማችን ተመልከቱ። ወደ ኋላ ልብሰዳችሁ። አሁን አላማችን ኦኬ ይሄን አገኘን። እቺን አንግል በዚች አንግል ሳብስቲቲዩት ማድረግ ነው፣ መተካካት ማለት ነው። ጥሩ እንደዛ ከሆነ አይታችኋል። ይሄ ስትሬት ላይን አይደል? ስትሬት ላይን ነው። ስለዛስ አንግል ቴታ ሲደመር አንግል ፓይ ስንት ይመጣል? 180 ዲግሪ። ጎበዞች አይታችኋል። 180 ዲግሪ ይመጣል። look here, theta plus pi is equal to 180 degree. why 4? because it is straight angle. look እንደዛ ከሆነ if so just take theta to the right side and then it becomes 180 degree minus theta which is equal to pi. ጥሩ ልጆች አይታችኋል። ይህ ሲምፕል ሂሳብ እንትን ነው። ስለዚህ ይሄና ይሄ እኩል ነው። አይታችኋል። ወደ ራይት ሳይድ ያለው ወይ በስተቀኝ በኩል ያለው ተርምና በስተግራ በኩል ያለው ተርም እኩል ነው አይደል? በእኩል በሆነ ነገር እናባዛ። let it be take one of the trigonometric function take cos። እስቲ በኮስ እናባዛ። cos ፓይ ይሆናል። ይሄ ደግሞ cos into 180 ዲግሪ minus theta ይሆናል። great። ከዛ ኮስን ደግሞ ዲስትሪቢዩት እናድርግ። ሎክ ስለዚህ ያልነው ነው ዲስትሪቢዩት ስናደርግ ትዝ የምላችሁ ከሆነ ይሄን ዲስትሪቢዩት ስናደርግ እሺ ሪማይንድ አድርጉ። ከሂሳብ ሌሰናችሁ ሪማይንድ አድርጉ፣ አስታውሱ። ይሄን ዲስትሪቢዩት ስናደርግ ኮስ ከሆነ ኮስ 180 ኮሳይን ኦፍ ቴታ፣ ይሄ ደግሞ መቀነስ ከሆነ መደመር አድርገን ነው የምንሄደው። ቀጣይ ደግሞ ሳይን 180 ሳይን ቴታ ብለን ነው የምንሄደው። ጎበዞች ሎክ ሂር cos pi is equal to cosine into 180 minus theta and then it becomes as what I said cos 180 cos theta plus sine 180 sine theta, but sine 180 degrees is 0, so 0 times any number becomes 0, and then cosine of 180 degree is -1, it becomes negative cos theta which is equivalent with cos pi. ታቻል እንዴት ይሆናል? ልክ አሁን እንዳልነው ይሆንና መጨረሻ ላይ ኔጌቲቭ ኮስ ቴታ ይመጣል ማለት ነው። በጣም ጥሩ። ታዲያ እንደዛ ከሆነ አላማችን እቺን ኮሳይን ኔግ ኦፍ ኮስ ቴታ ከኮሳይን ፓይ ጋር እኩል አይደለች? የቅድሟ ቀመር ላይ ወስደን እዚች ቦታ ላይ በዚህ ሰብስቲቱት ብናደርግ ምን ይሆናል? twice of AB into ኔግ ኦፍ ኮስ ቴታ ልጅ ስናስገባ ይሄ ይመጣልናል። ይቺ ስኩዌር ኦፍ r እኩል ይሆናል ስኩዌር ኦፍ a ማይነስ twice of AB cos ቴታ ፕላስ ስኩዌር ኦፍ b ይሆንልናል። ግን የኛ ዓላማ የአርን ዋጋ ማግኘት አይደል? ማግኒቲዩዱ ማለት ነው። ማግኒቲዩዱ ማለት አንደር ሩቱ ኦፍ ይሄ ይሆናል ማለት ነው። great. Therefore the equation becomes this one, and then cosine of pi substituted by cos theta, neg of cos theta, and then it becomes like this. But bear in mind the two different approaches yields the equivalent value for r on the mondatraso. Right. So this is the magnitude of the diagonal of the new vector is obtained using the law is known as cosine law. That is r is equal to square of a plus square of b minus twice of ab cos theta. ደግሞ ሌላ ነገር እንዳይመስላችሁ አይታችኋል። ስኩዌር ኦፍ ቅድምኛ ስንሰራ ስኩዌር ኦፍ a minus twice of ab cos theta እቺ ከዚህ ያልነበረች ስኩዌር ኦፍ b ይሄን ወደዚህ ብናመጣም ለውጥ አይመጣማ። ይችኛዋን ተርም እዚህ ጋር ነበረች እዚህ ብናመጣ ለውጥ ስለማያመጣ ነው። እሺ now the next important thing is finding the direction. To find the direction we have to use or we have to refer the sine law. Look my dears, direction is obtained using sine law. Sine law, sine theta over r, sine alpha over a, sine beta over b. Okay, great. What the meaning of component of vector? የዋንኛው ቬክተር ክፋይን ኮምፖነንት እንላለን። ይህን ክፋይ ደግሞ ለማግኘት አሁንም ትሪጎኖሜትሪክ ፋንክሽንን እንጠቀማለን። እሺ great. Components of the given vector A are obtained by applying the trigonometric functions of sine and cosine. Great. እስቲ ይህንን አሁን አይታችኋል። ዋንኛው ቬክተሩ A ነው። This is xy plane, okay? xy plane. So ይሄ ከሆነ ይሄኛው ቬክተር ዋንኛው ቬክተራችን ይሄ ከሆነ የዚህኛው ቬክተር x ኮምፖነንት ይሄ ነው፣ የዚህኛው ቬክተር y ኮምፖነንቱ ይሄ ነው። Look here. Vector A has x component and then vector A has y component. So to find the x component of vector A and then y component of vector A, we have to use a trigonometric function of sine and then cosine. So cosine of theta is equal to, as you know, adjacent over hypotenuse, and then ax becomes a cosine of theta, and then ay or sine of theta is equal to opposite over hypotenuse, and then ay becomes a times sine theta. Great. Now cosine of theta is equal to ax over a, that means adjacent over hypotenuse. This implies that ax becomes simply a cos theta, and then this could be considered as x component of a main vector of A. Okay, sine theta is of ay over a, that means opposite over hypotenuse, and then ay is simply a sine theta, or this implies that ay is equal to a sine theta. This is a y component of the main vector of A. Great. In such a way we find the components of the main vector. Great. The component ax and ay can be added to give back the main vector as the resultant. Great. ይሄን አሁን ሁለት የተሰነጣጠሩ የዋንኛው ቬክተር ስንጣሪዎችን ወይም የተሰነጣጠሩትን ብንደምር ተመልሰን ዋንኛውን ቬክተር እናገኛለን። So the magnitude of the resultant vector is obtained by using the Pythagorean theorem. Okay, Pythagorean theorem. That means square of A is equal to square of this plus square of this. Great. That means the magnitude of A becomes under root of square of AX plus square of AY. Great. Similarly, any three-dimensional vector A can be written as the sum of its x, y, and z components. Great. Great. Look here. This is the main vector within 3D, and then its components are illustrated here as what we did in two-dimensional vector. So a vector A is equal to simply its x component and then plus y component plus az, and then its magnitude becomes under root of square of ax plus square of ay plus square of az. Great. So direction mixed with the three axes is given by the direction of cosine, as what we did in the 2D. Everything is the same as what we have discussed earlier. Great. So vector in three-dimensional spaces. Another very important thing is the unit vector. Do you know about the unit vector? What the unit vector is? A unit vector is a vector that has magnitude of 1. The importance of a unit vector is to illustrate, to narrate, to show, to indicate where the main vector direction is. And then its magnitude is 1. So it is, the unit vector is dimensionless. And then its sole purpose is to point, to indicate a given vector in a specific direction. ስለዚህ ይሄ ዩኒት ቬክተር የምንለው መጠኗ አንድ ሆና ነገር ግን ዋነኛው ነገር የሷ አገልግሎት ዋነኛው ቬክተር አቅጣጫ ወዴት እንደሆነ የምታሳየን የምትመራልን የምትነግረን እቺኛዋ ቬክተር ወይም ቬክተር ዩኒት ቬክተር ይባላል። Great. It is usually denoted with a hat. For instance, look. This is the main vector, and then this is the magnitude of this vector. So this is the unit vector. Look, this unit vector acts as or tells to us about the direction of the main vector. Great. And then it always represented by what you call it a heart. Great. The vector, look, this is the main vector, and then this is the unit vector along x-axis, this is the unit vector along y-axis, this is the unit vector along d. So the main vector a becomes axi plus ayj plus azk, where ax is the component of the main vector a along x-axis. This is the component of the main vector along y-axis. This is the component of the main vector along the axis. Great. Vector addition in unit vector notation. Already we had seen. Look here. Vector A is equal to axi plus ayj plus azk. And then another vector B is illustrated like this. Bx, this is the x component of the vector b along x-axis. This is the y component of the main vector b, and then this is the z vector, the z component of the main vector of b. So if we requested to find the same values of vector a and vector b, what we have to do? Just we have to do like this. We have to sum the x component of vector a with the x component of vector b, the y component of vector A with the y component of vector B, the z component of vector A with the d vector of vector B, and then the sum of vector A and then vector B becomes ax plus bx along x-axis, and then ay plus b. These are the component of the new vector along y direction. This is the component of the new vector along z direction. Good. So the last subtopic of this session is finding the unit vector of the given vector. So the unit vector of the given vector could be calculated like this. We'll see in depth in detail by certain exercises upon a unit vector. Grab it and then put your comment. Even you have to share this channel for your friends. Till then, goodbye. Thank you a lot.